So this is Waves Homework Booklet question 28 and 29, couple of multiple choice questions. 28, we've got a diffraction pattern being formed by monochromatic light going through a single slit. If the width of the slit is reduced, which of the following is true? What will happen? So we're being asked about the width of the central maximum and the intensity. Now if I make that width smaller, then there is simply less light going through, so we are going to have a decrease in the intensity. The width of the central maximum. Essentially what we know is we get maximum diffraction where the wavelength is equal to the gap size. With light so narrow, it's such a short wavelength, we're always trying to narrow that wavelength to maximise that central, the width of the central maximum. So what is going to happen is I'm going to increase the width of the central maximum and I'm going to decrease the intensity of that central maximum. Using a diffraction grating with monochromatic light of 500 nanometers instant normally, a student found the second order maximum at a direction of 30 degrees to the bright central fringe. What is the number of lines per millimeter? So using n lambda as d sine theta, we can work out d n lambda over sine theta, 200 times 500 times 10 to the minus 9 over sine 30 leads me to 2 times 10 to the minus 6. Now we also know that we're after the number of lines per meter, so d is simply 1 divided by that number, so my number is going to be 1 divided by my value of d. 1 over 2 times 10 to the minus 6 is 5 times 10 to the 5, and yep, I can look and check and I do get 5 times 10 to the 5. The answer is D. So that was the Waves Homework Booklet questions 28 and 29.